Hi everyone, my name is Sakshi Nasha and I'm a software engineer at Cohesity. Today we're going to talk all about security in Postgres. Is your Postgres really secure or is it just working? Are you thinking of security as a design habit or just thinking it as an afterthought after you launch your product? So, if you have security in mind and Postgres, this talk is for you. Okay, let's deep dive from dev to prod. How can you secure Postgres the right way? Before we start, I would like to briefly introduce myself. My name is Sakshi Nasha, and as you know, I have been working in Cohesity as a software engineer where I build secure enterprise applications. I've been an open source contributor for more than 5 years now, and I have been contributing to Postgres, OpenSearch, Kubernetes, and a lot of open source applications. And I personally love connecting with people and communities. Until now, I have given 25 plus international talks on topics of Go, APIs, security, Postgres, and many other things to come up. Apart from work, I just love to play badminton, I love hiking and traveling all around the world. Okay, before we just start over right into security in Postgres, I would like to first touch on why does security really matter in Postgres, right? So that's about like why do we really need this? So most of the organizations these days focus on performance, shipping features first, while security remains a backseat. And it's mostly default driven. So maybe like default public schemas, default auditing, and when a big incident occurs, like when a leak credentials come up or it's misusing of roles, then the first response of many of the organizations is very reactive. And most of the organizations think of security as an afterthought and not as a design habit at all. And that doesn't really work in production grade applications. It should really be a design habit right from the planning phase. So here's the goal. The goal is to shift security from reactive to proactive approach. That is, taking it as a design habit right from the planning phase to not being an afterthought, right? So yeah, that's about it. And let me just walk you through one of the case study where, from my past experiences, how I have discovered few security blind spots that defaults that really work under development environment, but they don't really work under production. So let me just walk you through few of the security blind spots that we would like to just give a glimpse about. First of all, the most obvious part here is public schema access. So before Postgres 15, the public schema allowed really broader object creations by default. So if it is left unchanged, like if it is default, then it could really make users or applications create unintended objects. And these unintended objects in turn have a risk for permission misuse. So that's a security blind spot underneath, which can just point out to the default settings. The second one being an overprivileged roles, right? Like many teams use super user for migration, for maintenance workflows. So these super user roles, right, they have weak permission boundaries. By weak permission boundaries, as in like they have more permissions or maybe not the right permissions that are needed for the right job. If in case these overprivileged roles or weak permission boundaries are compromised, that's a big blast radius that's massive, right? And the key rotation, it's just a pain for cloud ops. So that's the first and the foremost thing is to have the least privilege principle that we're going to cover in future slides. And the third one being once you have all the roles, everything in place, then the client server communication that's unencrypted, right? That's potentially the third one, missing TLS. So the sensitive data, the queries, the passwords can be easily intercepted, right, at transit, right? So we don't really want our data in unencrypted format, right? So that security is at risk. So the fourth one is when you have default query auditing, or you have low level query auditing, or no query auditing at all. But the default is not capturing the information that you really need. Maybe standard logs aren't enough, way like which do not give details about who did what, when, was the access suspicious. So all this information when you really need, it's having a little more than defaults, right? So all these security vulnerabilities create potential risk in production, but in development environment, when the developers just test the code, it really works fine. So let me just walk you through one of the CVEs here that that is one of the critical CVE that got exposed in 2025. So in normal cases, when a user inputs the data, the developers often use Postgres functions like the escape string to sanitize the input, right? Before the input is sent to the SQL functions behind the SQL commands, right? So before entering this, it's sanitized, ensuring that the SQL remains safe. But under some edge cases, I mean, like there are misused encoding conditions, right? There are certain misusing encoding conditions. These functions did not fully sanitize or did not fully neutralize the escaping functions, and that really caused the SQL injection. And the mistake the organizations made here was over reliance over escaping APIs. And over reliance over escaping APIs caused the manual construction, and they were also relying on client side safety, right? Like they were assuming that the client side is very safe. So instead of adopting production grade practices like prepared statements, strict input validation, they were just relying on assumptions. And such vulnerabilities like CVE 2025 makes us remind that production security really depends on layered defenses. And we're going to talk a little more on which layers each by when we progress onto the slides. We'll cover layer by layer how defenses are being formed and not assume that they are in place, right? So, so that each edge cases like this one here, the encoding edge case must be checked and not assumed. And to read more about the security vulnerability, you can just scan the QR code to the right. And yeah, that was one of the case study that I wanted to cover. So now that we know what, why do we really need security as a design habit, and also we know what are the production blind spots, let's now bridge the gap between how organizations and developers can really early on do some things so as to avoid these incidences and make the database really resilient, right? So we'll talk about various rules here, like a layer approach. So the first one being limit your blast radius as much as you can, right? Like following the least privilege principle. So here we just segregate out various roles based on cases. For example, if we have application which uses migration, which is used for migration schema, or if we have admin roles, then we just define various roles. So in the screenshot, as you can see, I have defined various roles like app read role, app write role, and also I have revoked all the public schemas, right, as Postgres defaults may grant more than necessary permissions, right? And that's not what we really want. We define a clear permission boundary here. And then we can create role based on use cases. Like if we have application specific roles, then we just grant different object schemas there. So that's how we are defining a clear boundary here. And also, just to give you a short tip here, like we must avoid using super user, and this is like if super user is compromised, it's gonna just control the whole database because super user has all the permissions. But like you may ask me that maintenance jobs, some of the workflows in maintenance strictly need super user. Maybe they want to run analyze job, or maybe they want to run the vacuum functions, so they really need super user, right? Then how are we gonna follow this principle? So I'll pause here. I'll not tell you the answer right now, but stay curious until the last slide so that we can cover. There's something in the Postgres enhancements that cover this up. So just to summarize this, we must always keep in mind that every service should have only the permission that it absolutely needs. Absolutely needs as in no more, no less. That's what the basic whole fundamental rule one is. So let's just go on to rule number two here. Rule number two, so as Postgres deployment really grow beyond simple applications, role permissions really are not enough, like they're no longer enough for securing your production systems. Schema isolation becomes a real game changer here. When you think of schema changes in production, like in a stronger approach, is to have designing a schema with multiple design, right? Like when you have app, admin, audit. Like you can see in the screenshots, I've created schemas for app, I've created schema for admin, I've created schema for audit. So I have created multiple schema design, right? And I have also locked down the public schema to reduce the surface attack. So we have revoked all the public schemas to from the defaults, right? So the goal here is to move from convenience based development, like convenience based development as in when the defaults are just left like that, or when developers use shared public schemas, right? This is gonna work in development, but when you shift to production, they're gonna break, and that's gonna be a very weak namespace, right? And that's gonna increase the attack surface in turn. So we're gonna move from convenience based development patterns into intentional security boundaries. So, like, that's the rule number two. So, as privileges mode mature, namespace control becomes your next security layer. By namespace control, I mean security in terms of schema isolation, right? So that's rule number two. Let's go on to what we want to discuss. So, just to summarize, we had rule number one, where we were segregating roles and making specific roles for specific use cases. For rule number two, we just have different schemas, right? Multiple schema design. Let's go on to rule number three now. The rule number three is a little different from the standard basic one here. Like, while you have schema isolation, that protects the structural boundaries, right? Like structure, I mean roles, permissions. The search path is a little different, and that's gonna blow your mind because most of the production systems they don't really take this as a security setting. So search path is basically for somebody who is new, who is not aware. Search path is like controls, like it particularly controls how Postgres resolves object names during execution. So if you're calling a function name, from which schema, if you have not defined like schema dot function, if you have not defined that, from which schema will this function be called? So that is determined by the search path. And if you don't have the search path setting, right? If it's a very overlooked setting, by default weak or overly broader search paths configurations are what's the default in Postgres, right? So it really can allow redirection to malicious execution functions, right? Like for example, I'll give you a little low level example here, but we can understand the scope of it in enterprise applications. So for example, there's a function that you can see here that calculates bonus, right? In the public schema, define this function called bonus. It fetches data. It can fetch data from database, like tell me the current salary of the employee, and then I'm gonna calculate the bonus for it, right? And there's another function that I have created in the admin schema that is grant bonus, and which in turn you can see it's gonna call the calculate bonus, right? And that's calculate bonuses in the public schema, grant bonuses in the admin schema. Here, as you can see, I have one more default, which is security definer. So just to give you a high level overview of what security definer really is, it will execute this function, not like if you are calling from a different schema, grant bonus, it's gonna call this grant bonus not from the caller's privileges, but it's gonna call it from the admin privileges, the definer's privileges, right? So the grant bonus will be called with admin privileges. That's a little that's like gonna create a little more schema things. So let me just walk you through how malicious code can be infected here. So let's consider the same functions, right? Now the attacker comes in, it creates exactly same function, like exactly same as in function signature is the same, right? Calculate bonus is the same. It's defined in the public schema. It takes in the input, it returns input, right? So it's the same code, but underneath you're gonna see the select. It's gonna return 10 million bonus amount. I mean, yeah, I wish I could be that hacker so that I could get that much amount of bonus. But yeah, let's switch gears here. Now when this grant bonus is called, right? When with the admin privileges, when the grant bonus is called, it's gonna look at the search path. And if the search path is really weak, it's gonna redirect it. The function call is gonna redirect to the malicious code, the code that was inserted by the hacker, right? So this function execution from the previous calculate bonus, it's gonna call this calculate bonus, right? Because of the search path being very weak, right? The function execution got redirected. And that's not what we really want, right? The best practice in production is to harden this search path. So as you can see, in the later lines here, I have altered the function where I have given the function a specific search path being admin, PG catalog. So I restrict it to not have public schema at all, right? And then we also define qualified object names, right? Like schema dot object, right? Like that. And also we define a control definer functions. So as you can see here, I have defined the function that don't let it intended being called from a schema, public schema, right? Just make it call from admin schema. And all of the schemas, just don't let them call this grant bonus function, right? So with these practices, like we control who can execute the function, even with the definer permission, right? And also, we control which function should be called by hardening the search path. When you harden the search path, you can really define who calls it and which function can be called, right? So, hence, with the control execution path, it's very much essential, right, for having security privilege boundaries. And when I say secure privilege boundaries, it's not just about having right roles, having schema isolation, but also having the search path, the execution path of all the functions being very much defined and controlled. So yeah, I think now that we have covered how to secure the roles, how to secure the permissions, are we really good to deploy the applications in production, or is the design habit really done, or are we waiting for some bug to come up, right? So are we really good? I don't think we are really good here. We need one more parameter here because that's gonna be really a game changer, I feel. So, yeah, security does not just go in boundaries or securing the permissions. You need to also secure the data that stays in your database, on your disk, everywhere, right? You need to keep it protected while it's moving across the network as well, right? And so this brings us to really TLS coming up, right? So you need to protect the data in rest, data in transit. So just to give you a glimpse about how we can protect this data. So, without TLS, sensitive data such as credentials, queries can be really exposed in transit, right? And at rest, we must really make sure that our encryption is at the right place. Is it encrypting the data? And then is it storing it on the disk in the encrypted format? Are, are the backups encrypted? So, just to analyze this, why do we really want the data to be backed up and stored, right? If there is an infrastructure that is being hacked completely, right? If there's a whole infrastructure that is compromised, then the data that sits in, it's still in the encrypted format and the data is resilient after all, right? So that's the basic thing of ensuring that our data at rest is safe and resilient. Also, moving on to regular key rotations, right? That is really very, very tedious task for DevOps to short-lived tokens, or maybe workload identity federations where you don't really have to manage any of your credentials, right? So these short-lived tokens reduce the long-time exposure, and that's the main goal, right? Not manage the credentials at all. And there's also one more thing, which is we can avoid using like authentication methods that are legacy, using older password methods, to using Scrum SHA 256. That's really providing a more stronger approach towards authentication. And this one more thing here, which is when you are many of the developers or database administrators really don't take into consideration the configuration file of PG host based authentication, which was like pghba.config. They really don't take this into consideration, like who controls what. All of them is defined, like who can connect, where can it be connected from, what are the security requirements to get connected to this network. All of these uh, is defined in this file. So just to give you one short example here, let's consider if this is the host HBA file, and the first one being host SSL. So host SSL allow only SSL or TLS traffic, right? Only encrypted connections. And apply this rule to all the databases, apply this rule to all the users, right? And we are also doing an IP whitelisting here. Like as you can see, we are restricting the network range to come only from 10.0.0.0/24, right? So we are restricting those parameters as well. And we are also giving a stronger authentication method here, that is Scrum SHA 256. So, all in all, we are just having a stronger security, whitelisting it, allowing connections only from specific SSL connections, and applying it to all the objects in our schema. So that's the fundamental steps for securing data beyond the permissions, beyond schema isolation, beyond privileges, beyond role creation. We also secure the data at rest, we secure the data at transit. Now, let me just give you a glimpse over some of the recent security advancements that went in Postgres 17 and Postgres 18, right? So, in Postgres 17, there was a big announcement for maintenance workflows. I hope you remember in one of the slides we discussed we should not give super user, right, as the role for, or we should not grant super user to anybody, right? Then how do we do the maintenance job? So that's when Postgres 17 really made a game changer move here. There are two enhancements that for maintenance workflows that really went through. So in Postgres 17, they added a safer search path that handles that handles it really in a maintenance workflow, and it reduces the risk from unsafe object manipulation and unsafe function conflicts to really going into a safer search path. So that was the first enhancement that went through for the maintenance jobs. And the second one was they introduced a new role called PG underscore maintain role, which you can really use for all the maintenance jobs. So maybe if you want to do a vacuum, maybe if you want to analyze, maybe you want to re-index. So for all of these jobs where maintenance usually want to use these functions, they no longer depend or they no longer grant the full super user, right? They really just use the PG maintain role and they're good. So that's when that really changed, right? That we can now follow the least privileged model with Postgres 17 new enhancements. Also in Postgres 17, like I still remember I gave a talk in Postgres Europe last year in Riga, Latvia about incremental backups, right? How we can have incremental backups that supported in Postgres 17. So in Postgres 17, from the basic backup, they moved on to incremental backups that would really support into providing operational resiliency and backup security after all, right? So yeah, you can you can just scan the QR for more updates on what are the other security enhancements that went through for 17, 18, and if you want to give a detailed understanding about it, you can just scan this. For Postgres 18, they introduced the OAuth support. So with this OAuth, you can really integrate external IDPs, right? Maybe SSOs, maybe other federated identities. So you can just include all of these integrated onto these Postgres, right? So, yeah, that's about the two major enhancements that I personally think, from a security point of view, they are really important and they really changed many of the production grade applications. These were the enhancements that really like they clearly prove that Postgres is evolving towards more secure production environments rather than keeping it to defaults. So, yeah, I think we've covered most of it. So, yeah, just let us move towards how we can move towards the security. Let me just have a checklist, like what all we covered. So, firstly, just identify your security blind spots, right? Identify it at the right place and revoke the all the unsafe defaults, right? Don't assume anything, right? As we covered in the case study, they assumed that the escaping APIs, the over reliance over them, right, really was a big pain for them. So don't just assume it, identify your blind spots, revoke all the unsafe defaults. And the four rules that we discussed: define the clear permission boundaries by having least privilege model. Then have the namespace control over it so that you have schema isolation. And once you have all of these into place, you also want to have a control execution path. So control execution path can be achieved via hardening the search paths. You also secure the security definer usage, like which schema can call the security definer usage, right? With all of these, you achieve security in the permission boundaries, right? Restricting a clear boundaries. But when you want to move towards beyond data, that is when data at rest or data at transit comes into play, right? So you enforce TLS, you encrypt the data which is stored and also back it up. And also you configure PGHBA config files, right? So these are some of the tips that I had for covering all of the security parameters. And stay tuned for more PG releases here, right? So, yeah, that's all that I had for today. I hope you learned something new, and I hope I have convinced you enough to make security a design habit. And I hope to connect with you if you have any questions. Scan this QR, connect with me on LinkedIn, and I would love to hear your feedback and improve further. Last but not the least, thank you to Postgres, the whole entire team, Linda, Isaac, Corning, everybody who really made this possible, and they gave me an opportunity to to just be here and share my thoughts. Bye until next time.